Hi, welcome back. Today we have a question which is dam is a quarter circle 50-meter wide into pitch. Find the horizontal and vertical components of the hydrostatic force against the dam and the point CP center pressure where the resultant strike the dam. Alright, so what we need to do in order to get to the solution. All right. The first step, we need to understand the question. So first highlight, find the horizontal and vertical force against the dam and the CP point where the resultant strike the dam. All right. So the first step, we need to draw the free body diagram. All right. So from here, try to extract where is the force involved. All right. Definitely CP is where the force is located. That means we have the horizontal force and we have the we have the vertical force. All right. Let's say the vertical force acting toward the center of this quarter circle. All right. So first we need to find the magnitude of horizontal force, which is FH. All right. You can see here FH. All right. Equal to gamma of water multiply with the HC. All right. The height from the surface to the centroid and then multiply with the area. What's the area? The projected area. So this is the curve and then we project into the liquid and then this is the projected area. As you can see here. This is what we call a projected area. So it is given that the density multiplied with the gravity is the specific weight. So here is actually the specific weight where rho multiplied with gravity. So rho of water here is 1000 multiplied with the gravity. So it is 9810 multiplied with the HC. Alright. So for this case, you focus on the focus on the projected length. So from the surface to the bottom is 20. That means the centroid is at the middle position. So it is 10 meter multiplied with the projected area, which is 20. When we try to draw like this, it is into the page. Okay, it is 50. And then this is the height. So, in order to get this area, which is 20 multiplied with 50. So, you will get here roughly around, okay, 97.9 multiplied with 10 the power of 6 Newton. Right? And then you need to find the vertical force, which is FV. Okay, so for the vertical force, okay, which is based on this liquid solely. All right, so on top of this curve, it is only liquid, and you can see this is a reference line. That means we ignore the atmospheric pressure. There is no pressure on the free surface. Okay, so we only have the vertical force due to this weight. So how to calculate the vertical force? It is just only the weight of the water, which is weight of the water equal to mass multiplied with the gravity. Okay, so what's the mass? We know that density is equal to mass over volume. In order to get mass, density multiply with volume. So end up you will get rho V and G. Rho and G we consider as a gamma of fluid multiply with the volume of this quarter circle. Okay, so for this case, gamma of water, which is 9810, okay, multiply with the volume of this. Okay, the volume of this. Okay, we need to consider this is just a quarter circle and then it is into the page. Okay, you need to consider as well the volume. So what's the volume that you're going to discover? So it is pi. Alright, what is the surface area here? Pi d squared divided with 4. Alright, so that is the diameter. Alright, you can use the radius. So here, in order to get this, the area of quarter circle, which is pi r squared. Okay, since this is 1 over 4, divide with 4. So pi r, which is 20, squared divide with 4. That is only the area. In order to get the volume, multiply with the depth. Okay, into the page, which is 50 meter. End up, you will get the value is 153.78 multiply with 10 the power of 6 Newton. Alright, so that is the magnitude. So the question asks the locations. Alright, means the direction. So how to get the direction? Okay, so what to do next is we need to find the, okay, let's say this is the FH. Where is the location of horizontal force? In this direction. So we're going to use the IXX. Okay. We're going to use the we're going to use the YCP, which is equal to negative IXX sine theta over HC multiply with the area. Okay. Okay, so based on this formula, just substitute the second moment of area, which is IXX, for this projected plane, which is, okay, 1 over 12 BH cubic. So how to get the H? Remember that the H always parallel to the plane. Okay, can you see this is 20? Definitely your H is 20 and then your B should be into the page, which is 50. Okay, so just substitute the equation. Negative IXX, which is 1 over 12, multiply with the B, which is 50, multiply with the H, which is 20 cubic. Okay, and then multiply with the sine. So what's the angle of this plane to the horizontal? Definitely it is 90 degree. So sine 90 degree over with HC. Okay, so HC is 10 because 20 divided with 2 is 10. Multiply with the area of this projected plane, which is 20, multiply with 50. So end up, you will get the Y, okay, YCP is equal to negative 3.33 meter. Okay, so the final point of the HCP, okay, it is actually, this is the centroid, and from the centroid to the CP is where you need to find. So for here, the HCP, therefore, the HCP is actually from the surface to the point CP is, this is half, which is 20 divided with 2, which is 10, plus this value. Alright, when you plus, don't consider negative because it is below the centroid. So 3.33. So you will get 13.33 meter from the free surface. That is the point of FH. How to get the location of FV? Okay, the location of FV. Okay, how to do that? So this is the step. The FV will act at the centroid of the quarter circle. So maybe this is the FV location. Okay, so how to get this centroid of the quarter circle? Refer to this table, the geometric property of line and area element. You look at the quarter circle and you realize that in order to find the centroid where the force will act, which is 4 over 3 r over pi. Okay, so in order to find the location, okay, you need to find the center of quarter circle or centroid. Okay, centroid of quarter circle, which is given from the formula 4r over 3 pi. So, for radius is, radius of this quarter, which is 20, multiply over 3 pi. And you will get 8.49 meter. Alright, so 8.49 meter is actually from the center to the centroid. Okay, so for this case, okay, it is, where is the center? This is the center. Okay, this is the center. From the center to this is actually 8.49 meter, where that is the location of the vertical force. Okay, so that is the location for the FV. Therefore, that is the final answer to get the magnitude of horizontal and vertical forces, as well as the location of those forces that reflect to the CP. I think that's all. Thank you for your time.